All right, we're going to do an example of finding slope in polar. So we're going to say let r equal 2 cosine theta, and we're going to find the equation of the tangent line when theta equals pi. All right, so remember that anytime we hear the phrase equation of a line, right, forever and always, we need two things. Number one, we need a point, x comma y, right, x comma y. And number two, we need a slope, right, which in calculus is generally the derivative, right? So our slope is dy dx, right? So I'm going to go ahead and start by finding the point, right? So from a previous video, we've talked about converting from polar to rectangular, that x equals r cosine theta, which in this case is going to be r, which is 2 cosine theta, right? And my y is going to be r sine theta, which is going to be a 2 cosine theta sine theta, right? So that means that I can use those two formulae to find the x and y points at the moment when theta equals pi. So when theta equals pi, the x coordinate, so x of pi, rather, right? X of pi. Is going to be a 2 times a negative 1 times a negative 1, meaning my x-coordinate is a 2. And my y of pi is going to be a 2 times a negative 1 times a 0, so it's going to be a 0. So I now know one piece of this information, right? The first piece of information I know is that the point I should be using is 2, 0, x, y, right? The second part of this work, so that takes care of the point, right? The second thing I'm going to have to do is find the slope, and that's a little bit more tedious. So it's kind of worth noting that x is the same as 2 cosine squared theta rather than just treating it as a cosine times a cosine. You don't have to do this, but I think it's a lot easier to use the chain rule than it is to do the product rule. It doesn't matter which one you pick. And I'm going to leave the y as a 2 cosine times a sine. If you wanted, you could also use the identity that that's the same as sine of 2 theta, right? So if you liked this better, you could actually make this sine of 2 theta. Again, I think that's slightly easier. It's up to you. I'm going to use these easier versions instead of using the product rule. So my y prime of theta, right, should be the derivative of sine of 2 theta, which is going to be the derivative of sine, which is cosine of 2 theta, times a 2. And on the bottom, I'm going to do so that's my y prime, right? And over my x prime of theta, right? And so my x prime of theta, if I put that on the bottom, is going to be the chain rule here. So the derivative of 2 cosine squared theta is going to be a 4 cosine theta, right? 4 cosine theta, times the derivative of cosine, which is going to be a negative sine, right? So essentially, my dy dx is a 2 cosine of 2 theta over a negative 4 cosine theta sine theta, right? So when I go to find my tangent slope is going to end up being a 2 times a 1 over a negative 4 times a negative 1 times a 0, meaning I end up getting an undefined slope, right? So after all that work, right, undefined, okay, so after all that work, it turns out that the equation of the tangent line is a vertical line through the point 2, 0, which means the tangent line is just x equals 2. But you can't know that until you find the slope as undefined.